So, what if I told you that one single day on the calendar could connect, say, ancient Greek puzzles with the jumbo jets flying over our heads right now? Well, today we're going to dig into April 12th. Turns out it's a surprisingly important date in the whole story of mathematics.
April 12th. Now, I know what you're thinking. It probably doesn't seem all that special at first glance. But believe it or not, this one day is like a major crossroads for some of the biggest ideas that literally shape the world we live in today.
Yeah, from those ancient puzzles all the way to modern airplanes. There's this sort of invisible thread connecting everything. And you guessed it, it runs right through April 12th. So let's follow that thread, okay? We're going to start with a puzzle that's literally 2,000 years old. All right, our first stop is going to take us way back in time. We're about to face a mystery that stumped the absolute greatest minds for, get this, over 2,000 years. Okay, think about this for a second. Let's say I gave you just a ruler and a compass, nothing else. Could you draw a perfect square that has the exact same area as a circle I just drew? For literally thousands of years, the smartest people on the planet tried, and every single one of them failed. It felt impossible, but nobody could figure out why. So it turns out the secret wasn't some new drawing trick. No, it was hidden in the very nature of a single, very famous number. And the whole story, our answer, really begins on the day a guy named Ferdinand von Lindemann was born. Okay, so Lindemann's big proof was all about this really fascinating property of pi. He showed that pi is transcendent. Now that's a big fancy word, I know, but all it really means is that pi is a special kind of number. You can't get it as the solution to any simple algebraic equation. It's different. And because it's so unique, Lindemann proved that it's just physically impossible to build that square with the same area as a circle if all you have is a ruler and compass. It's a flat-out geometric impossibility. So here's the kicker, the really crucial part. Lindemann's huge victory wasn't actually solving the puzzle. It was proving with total mathematical certainty that it could never be solved. He's the one who gave the final, definitive no way to a question that had been around for 2,000 years. Okay, now let's fast forward a lot. We're leaping forward almost 150 years, but we're staying on the exact same date, April 12th. And we're going from this ancient, abstract puzzle to a very, very modern problem. I mean, have you ever really wondered how modern airplanes can have these incredibly powerful jet engines that are somehow way quieter than they used to be? If you've ever been near an airport, you know exactly what I'm talking about. But today's planes are so much quieter. And that didn't happen by accident. Nope, it's all thanks to some seriously complex math. And of course, the story behind all that math connects right back to our date, April 12th, 2000. That was the day we sadly lost David Crighton. So this guy, Crighton, he was an absolute expert in acoustics. That's the science of sound. He used math to understand how sound waves are born from all that turbulent, messy air rushing over a jet's wing. I mean, it's total chaos. But his work, his math, directly helped engineers design quieter planes, especially for those loud takeoffs and landings. I mean, think about that. The next time you hear a plane flying overhead and it's, well, quieter than you'd expect, you're basically hearing the echo of his math. It's amazing, right? All right, we're sticking with April 12th, but now we're going to switch gears from engineering to something even more fundamental. We're talking about the perfect test. So when scientists come up with a new medicine, or maybe a new fertilizer for crops, how do they design an experiment to prove that it actually works? I mean, really works. That's a huge question, right? Because getting it wrong could be a massive deal. For this part of the story, we've got to go back to April 12th, 1900. That's when we meet the person who helped answer this very question, a man named William Youden. Youden was a statistician, and what he did was invent entirely new ways to design experiments. He came up with something called Youden Squares, which are these clever ways to test a whole bunch of things all at once. This helps reduce errors and saves a ton of time. His techniques basically make sure that when scientists get a result, it's reliable and not just, a random fluke. You could say he gave science a much better recipe for finding the truth. He's the guy who built the toolbox that other scientists use to make their amazing discoveries. Okay, for our last story, we're jumping right up to the modern day, almost to the present. We're talking about the virtual blueprint. Seriously, how can engineers crash test a new car 1,000 times or test a brand new bridge design against an earthquake without ever building a real one. I mean, how's that even possible? Well, our final answer comes from a very, very recent event, April 12th, 2023. That was the day we lost Ivo Babuška.
See, Babuška was a world-class expert in something called the Finite Element Method. It's a really powerful mathematical trick that lets us take super complex things, like a car or a dam, and break them down into tons of tiny, simple pieces. A computer can then simulate all the physical forces on those little pieces, which lets us test and perfect our designs completely in software. It's like building with digital Legos to see what will happen in the real world. And because of his incredible work, we can now build and test the future on a computer screen first. It's a total game changer for modern engineering. So, okay, we've met 4 absolutely brilliant people, separated by centuries, working in totally different fields, but they're all connected by this one single day. So, what's the one big question? Just to recap, we've got Ferdinand von Lindemann from 1852, William Youden in 1900, David Crighton in 2000, and Ivo Babuška all the way in 2023. 4 people, 4 different worlds. Yeah, they came from different centuries, completely different fields. So what's the real connection here? What ties them all together? Well, they all looked at a complex, chaotic world, and they all asked the same really powerful question: what is the hidden pattern here? That's it. That's the connection. And look at what their answers gave us. Quieter planes, better science, virtual design. It just goes to show you, their work on this one day, April 12th, reminds us that the answers to our biggest challenges might be hiding in plain sight, just waiting for someone to find them. So, the real question is, what hidden pattern will you discover next?